Alright, so today, or this video, we're going to discuss the actual call that you use to get dynamic memory, and that call is malloc. Now malloc returns a pointer, which is the type of which is a void pointer. And a void pointer is one of those, it can be anything. Pointers on the machine are always going to be the same size, and as I hope you realize by now, that it's the data type of the pointer that sets how that memory address is being used, whether it's pointer to an integer or pointer to a character or whatever. That's how that memory is being used. A void pointer doesn't have any particular type, but when you assign it to a pointer of a particular type, then that memory that is assigned to that address, where that address is being used, is going to be used in the manner of that memory type. Anyway, so inside malloc, there's a parameter, just a single parameter, and that's the size in bytes of the memory that you're going to be using. So let me just give a simple example on how this would work. So let's say we want to make an array of doubles, and perhaps we have the user input the size that they want. We'll just sort of, for now, use some value like 15 or something. So we would declare that as double, and let's see, I guess we'll call it D pointer, or D array. And we'll go ahead and set this equal to null at the beginning. Alright? And by the way, so over here we'll have our memory representation. And this part right here will be D array. And let's say that this is at memory address 3000. Let me make sure that's actually seen by the video here. Nope. Okay, so let's adjust this a little bit. Okay, I think you can see that now. Okay, so this is at memory address 3000, and we're assigning the value null to it, so this is going to get the value null. So now we're going to do our call to malloc, and the way we do that is we use D array is equal to malloc. Now I said that we're going to try to allocate 15 doubles. So we would do something like this: 15 times size of double. And that is going to go to cause the operating system or the program to go to the heap, find a place that can hold a place of memory that's available that would fit this size. And in this case, if we're saying that a double is, say, 4 bytes, then it's going to be 60 bytes. It's going to try to find a place in the heap of 60 bytes of contiguous memory, and then it's going to return the address of that particular area in the heap. So let's say that I have this is my heap area, and I have some parts of it being used, but there's some other parts that are free. So these are the free parts. Let's say that right here, the operating system says that, oh, here's 60 bytes of free memory, so I'll return that address. Let's say that address is 10,000. Okay? So here, this is 60 bytes. And so now we have a memory area of 60 bytes that can be used by our program, and we return the memory address of that particular block of memory. And since we're returning that, it's going to be stored in D array. So this is no longer null. It is now the value, or the memory address, 10,000. One thing that we have to be careful of: whenever we use malloc, we always need to check what the return value of malloc is. There could be a situation where there isn't any place in the heap where there's 60 bytes of contiguous memory. If the operating system can't find that location of 60 contiguous bytes, it has to return something, but it has to return that it couldn't find anything. So the return value it would return in that case would be a null. So after every single call to malloc, you need to check the return value of it to ensure that you actually have something instead of a null pointer. So that's very easy to do. You just do if darray is equal to null, then you're going to print some sort of error message. And then for our programs for this class, we won't worry about trying to handle it in any particular way. We'll just exit. Okay? So, after every call to malloc, you need to have a check to see that that memory is actually there. Sadly, people get used to machines that have so much memory that there's hardly ever a time when malloc doesn't return null, but if you want to be a good defensive programmer, you need to do that every single time because you never know. Unfortunately, a lot of programmers get sloppy and they do that. Years ago, Microsoft, the Windows operating system, used to have what they called the blue screen of death. Many times you get the blue screen of death because the operating system would make a call to the heap memory, not be able to find enough memory to handle that call to malloc. It will return a null pointer, but the programmers who were programming it would not check the return, and they'd go ahead and try to use that memory anyway. Well, if that memory doesn't exist and you try to use it, it causes a segmentation fault or blue screen of death on Microsoft. So always, always, always check the return call to malloc. Just like when I say checking the return call, the return of your call to fopen. You always, always, always want to check the return call of malloc and fopen. And by the way, since we're talking about fopen, the other thing that we always need to do when we use a call to fopen is we have to close the file with fclose. Malloc has a very similar thing where when you're done with the memory, you don't need it anymore. You want to be a good steward of your operating system and return that memory back to the heap so perhaps some other process could use it. So the way you do that is with a call to free. And it will take free, and then it's just the name of the particular pointer. In this case, it's going to be free memory address 10,000. And so that memory that was allocated for your program is now going to be freed up for some other process. Okay, and this is something you always want to do. For every call to malloc, there should be a corresponding call to free. In a couple weeks, we'll be using the tool called Valgrind that will help remind you if you forget to do that. But there's also some problems if you don't do that, which we'll go into in a later video that can show the kind of things that can happen if you forget to free your memory. So let's just go on now, and we'll assume that we did our malloc and we got our memory and so forth. How do we use this once we've got that? So just assume that we have our memory check, and our free will come down later in the program. But now that we have this array, we can use it just like we can any other array. Even if we had done something like D array, well, I'd have to do a double. D array 1, and let's say that I'm going to make that of size 15. Okay? So if it's D array 1, you should all be used to this by now. You can do D array 1 or 5, or let's do 5. D array 5 is equal to 120.3, something like that. So you can use that array that you declared in this manner just like you've been doing so far. You can do the same exact thing for D-array. Because of pointer arithmetic, which hopefully you've gone through and you understand pretty well now, you can use the pointer arithmetic method to assign values within the memory. Okay, so basically, I'll just show you the easy way to do it. You can D-array 5 is equal to 120.3. So you can do the exact same thing because of pointer arithmetic. This just actually can be also thought of as D-array plus 5 equals 120.3. It's just this notation is a little more convenient than doing this as far as doing that. So what does this actually mean? Well, D-array is set to 10,000, the memory address 10,000. So we're going to do 10,000. D-array is a double pointer, so it means it's going to go 5 elements of double in the memory, which is going to be each double is 4 bytes, so this is going to be 20 bytes. So this is actually modifying the memory address 10,020. So way over here, way far away from your program, is going to be that area right there. Say that's memory address 10,020. That's going to be the actual memory address that gets modified. In later videos, we'll show this in a little bit more detail. Maybe not specifically for dynamic memory, but certainly some other cases we'll have that memory, and we'll show you a little bit in more detail on exactly how that's going on. But all this is doing is you're assigning the value 123 to the 5th element of D-array. D-array is pointing to memory address 10,000, so it's going to be the 5th double element in that memory block. That's what's going to be acted on. You either read to it or write to it or whatever. So that's basically how the use, simple way to use dynamic memory for your arrays.